Alright, in this video I'm going to be going over some of the algebra skills that you're going to need when you're in Chapter 6. And on number 1, we did some radicals in the Chapter 5 review stuff, but I want to do one more here. Of course, by definition of an exponent, this means x plus the square root of 3 times x plus the square root of 3. And actually, before I go any further, I should probably encourage you to try to do these problems on your own first. Or there may be some where you're like, I know I can do that one, and you don't need to worry about it. And then watch the video and check your answers for the ones that you decide you want to practice. There is one more problem. It's number 5. You do want to make sure you know the quadratic formula. That's something that you should have memorized. All right, let's go back to number 1. Oops, let me just fix this a little bit. There we go. Okay, so we're on number 1. And of course, we're going to want to FOIL this. So we'll multiply our first terms. We get x squared. We'll multiply our our outer terms. X times square root of 3. Let's go ahead and put the x in front. I can't multiply those together. They don't belong both under the radical, just the radical 3. Okay, and then we'll multiply the inner product, and we get another one of these, and again I'll put the x first. And then here, when you multiply square root of 3 times square root of 3, you should get 3. Hopefully you know that rule. Basically, square root of 3 times square root of 3 is the square root of 9. That's how we multiply radicals. Oops, let me go down just a bit. But the square root of 9 is 3. And so anytime you multiply a square root times itself, you're going to end up with the number inside. All right, so let's finish the problem here. All right, so we have two like radicals here. Like radicals have the same radicand or number under the radical, and they're both the same root. So these are both square roots. They both have 3 under the radical, so these are like radicals. And so just like we would combine like terms, we're going to want to add the numbers out in front in order to combine these. So this becomes x squared. X plus x is 2x, so we get 2x times the square root of 3, and then don't forget the 3. And so you're going to have to do some similar types of multiplication with trigonometric expressions, and so this is a skill that you're going to need. All right, on number 2, it says find the inverse of f of x equals x squared plus 3, where x is greater or equal to 0. So you might be wondering, why is x greater or equal to 0? Well, hopefully you remember this is a parabola that has a vertical shift that's been moved up 3, or a vertical shift of positive 3. And so when you're dealing with inverse functions or inverses, you can only take an inverse of certain kinds of functions and get another function. Now, this is a function. In fact, it does pass the vertical line test that you should have learned back in algebra days, but it doesn't pass the horizontal line test in order to be a one-to-one function. And that's what we need in order to have an inverse that's going to be a function. And so basically, because this doesn't pass the horizontal line test, we know it's not one-to-one. So what we do is we basically will restrict our domain so that now we're just looking at the piece of the graph where x is greater or equal to 0. And notice now this is a one-to-one function. It does pass the horizontal line test. All right, so now let's go ahead and find the inverse. So the first thing you want to do when you find an inverse is you change to the y notation, and this is y equals x squared plus 3. And we want to remember that x is greater or equal to 0. And then the key step when we're finding an inverse is to interchange x and y. Y becomes x, and x becomes y. Now keep in mind when we do that, before x was greater than 0, now that we're interchanging x and y is going to be greater than 0. And so the next step is to solve for y, and so we'll subtract 3 on both sides. We'll get y squared is equal to x minus 3. And I'm going to go ahead and put this over here, y squared equals x minus 3. I'm just going to switch sides. As long as two expressions are equal, it doesn't matter which one you put on which side. And then to solve this, I'm going to have to take the square root of both sides. When I take the square root of y, the square root of y squared, I get y. And when I take the square root of x minus 3, we're going to have the square root of x minus 3. Now you may recall when you do that step, you need to do the plus or minus thing. In other words, if you solved x squared equals 64, for example, and you took the square root of both sides, you would get x and 8. The only problem is negative 8 squared is also 64. And so when we take the square root of both sides, we got to do this plus or minus thing. We end up with two answers. All right, so same thing here. This should be a plus or minus. But remember, we said y is greater or equal to 0, and so we know that y equals the square root of x minus 3. And the only thing left to do is use the inverse notation. We're going to replace y with f inverse of x, and that's equal to the square root of x minus 3, and that's going to be our answer. All right, let's look at number 3. Now, on number 3, we're solving for x. This is actually a linear equation. We don't have any higher powers of x, and so normally all we need to do with a problem like this is isolate x on one side. So first of all, I would want to subtract 1 on each side. You get 2x equals negative 1. And then we'll divide each side by 2. And so we're going to end up with x equals negative 1/2. And so that's how we normally would solve a linear equation. We didn't really need 0 on one side. Our whole goal in solving this equation was to get x by itself. Now, when you solve quadratic equations, things are different. Your approach is going to be different. And we're going to use a property called the zero products property. And you probably don't remember it as being called that, but that's a property that we use when we solve problems like this by factoring. All right, so on letter A here, a common mistake that students make is they'll divide both sides by x. The only problem with that is we end up losing one of our solutions. And so what we want to do instead is subtract x on both sides, because notice we have a common factor of x in these two terms. So what times x is 3x squared? Let's see, we're going to have x times two terms. So x times these two terms should give us what we have here. So we're going to need a 3x. That product there will give you that. And then notice this would be a minus 1. X times a minus 1 gives you the minus x. Be careful, sometimes when it's 1, students struggle with that step. And so don't forget, that's equal to 0. And so now we have a product of two numbers that's equal to 0. Well, anytime two numbers multiply to 0, one of the two numbers must be 0. That's what we mean by the zero product property. So either x is 0 or 3x minus 1 is 0. So notice we already have one of our solutions here. And then now we have a linear equation that we can solve. Let's add 1 to both sides and divide by 3, and we get 1/3. And that's our other solution. Notice with the linear equation we had one solution, which is what we normally would get, or no solution. Whereas here we're getting 2. So with quadratic equations, notice the x squareds here, you should be expecting 2 answers. It's very possible that you'll get 2. All right. On letter B here, notice this is a trinomial. This is something you ought to be able to factor. Now, in the videos that I made, or that I've made available to you under the Chapter 5 review, there's a method called the AC method where you can learn how to factor trinomials if you forgot. Hopefully you can factor all of these trinomials. One of the things, though, that I found is they keep the numbers pretty reasonable in this course, and we can factor these without a lot of trouble. So let me show you how I would encourage you to factor these. This may be enough to get you through Chapter 6, but again, if you need more help on factoring, I would encourage you to watch those videos in the Chapter 5 review. Or there was a video on the AC method. All right, so for 4b, well, actually, I'm going to go ahead and do a problem up here. X plus 2 times x plus 3. If you FOIL this out, you'd have x times x is x squared. You'd do x times 3, you'd get 3x. 2 times x is your inner product, and your last product is 6. You get x squared plus 5x plus 6. Notice that the x squared comes from these first two terms being multiplied, and the 6 comes from the last two terms being multiplied. Where does that 5x come from? Notice the last two terms added gives you 5x. Now, be careful here, because what if this had been instead, let's call this 3x plus 1 times x plus 2. Well, you would do the same thing. You'd FOIL this out. You'd get 3x squared. You'd multiply your outer terms. You'd get 6x. Your inner terms, you get x. And your last terms, you get 2. So you end up with 3x squared plus 7x plus 2. Now, when you go to reverse the process and factor, notice this 3x squared, again, came from the first two terms being multiplied. So if I were trying to figure this out, I'd have an x here and an x here. The nice thing here is 3 times 1 is the only way to get 3. So I'll put a 3 there, and that's understood to be a 1. And then notice the 1 times 2 gave us this 2 here. So when we're reversing the process, we're looking for two numbers that multiply to 2. Now it turns out that the order will matter here. Either the 1 will go here, or the 2 will go here, and the other number will go here. Now what's the key thing here? Notice this time that 1 plus 2, they do multiply to 2, but remember how over here we had 2 times 3 was 6, and 2 plus 3 was the 5. It doesn't quite work that easily with these, and it's because of this 3 here. Notice 2 plus 1 is 2. I'm sorry, 2 times 1 is 2, but 2 plus 1 does not give you the middle term. So it's this 3 that messed things up. But what we do have is an inner product of 1x and an outer product of 6x. That's where we're getting that middle term. So if I'm reversing the process here, I'm going to put my 2 here, or 1 here and my 2 there, and if that doesn't work, I'll switch it up and try the 2 here and the 1 here. But notice we have a 1x and a 6x, and that does give us the 7x, and so this is the right combination. All right, so let's go ahead and do this now. So here it's going to be x and x that gives us the x squared, and this is really nice because 1 times 1 is the only way to get 1. Notice everything's positive here, so I'm going to put pluses in here. Notice your inner product and your outer product do add up to 2x. 1x plus 1x is 2x. And so we've got this factored correctly. This is called factoring by trial and error, what we're doing here. So we have x plus 1 equals 0, which means x equals negative 1. Notice I said before, normally you get 2 solutions with a quadratic equation. In this case, we actually get 1. And you may recall from college algebra, this is what we call a repeated solution. We would say it has a multiplicity of 2. The solution negative 1 has a multiplicity of 2. That's not so important. Most important thing is that you can do what we did here. All right, so let's go ahead and do the next one. So again, we're doing this using trial and error. Now, we know it's going to be x and x. These will multiply to give us the 2x squared. And again, 2 times 1 is the only way to get 2. So I'll usually put my bigger number here and my smaller number here. So 2 and 1. Again, 1 is the only way to factor, or 1 times 1 is the only way to get 1. So we know that's right. Now be careful here. Notice when we multiply these two numbers, we get a positive 1. That means they're both positive or both negative. But because my middle term's negative, they must both be negative. So let's see if we have this right. Notice we have a negative 1x for the inner product and a negative 3 or 2x for the outer product. And notice that does give you a minus 3x. And so this is correct. And let's see, we're going to get 2x minus 1 equals 0, or x minus 1 equals 0. We get 2x equals 1, which means x is a half. Just divide both sides by 2. Over here, we're going to get 1. Just add 1 to both sides. I think I'm going to go ahead and stop this video right here, and I'll do a second part for the last 3 problems.